Hey, lead code fam, welcome back. And today let's solve lead code 48, rotate image. And yes, the question is again pretty straightforward. We'll be given an array of numbers and we'll call that an image. And we have to rotate it in place. We can't use extra space to do that. That is important. And what does rotating mean? Just imagine you have a square sheet of paper and turn it once in any direction. Over here it is asked to rotate it 90 degrees clockwise. So yeah, hold a piece of paper and rotate it clockwise by 90 degrees. And what you'll have, that should be the resultant array. And yeah, again the question itself is pretty straightforward, and the question can't be explained further and it can't be broken down into smaller pieces also, because yeah, it is really the problem statement is really easy, and you have to come up with an algorithm to do that. And what most places what they teach is that first we'll remove one and we'll keep it in a temporary variable, and then we'll take 7, put it in place of 1, we'll take 9, we'll put it in place of 7, we'll take 3, put it in place of 9, and then we'll take the temporary variable and we'll put it in place of 3, and then we increment the pointers. Yeah, this is what is being taught mostly, and yeah, that is also a valid approach, but that becomes really complex to understand for like new people and all. So today I'll show you another way to do this, and yeah, it involves knowing what transposition of a matrix is. And transposing a matrix is nothing but interchanging all the rows and columns. So if we have an array, one we have array of 1 2 3 4 5 6 and then 7 8 and 9. So what does transposition mean? Interchange all the rows with all the columns, so it will become 1 4 7 2 5 8 3 6 9. Yeah, this is what a transposition is. We just interchanged all the rows and columns. 3 became replaced with 7, 7 with 3, 4 with 2, 2 with 4, 5 with 5 will stay as it is because it is the center of the matrix, 6 with 8, and 8 with 6, and 9 will also stay the end. And one thing to note is that when you transpose a matrix, the diagonals will always stay the same. The principal diagonal, it's called. And okay, and now you tell, okay, what will you do with just transposing? And now just look at the resultant array of transposition and the answer. What we can note is that the resultant array itself is the output, but each row is reversed. So for example, if you go through our transpose matrix and reverse each rows, what will happen? 7 4 1 8 5 2 and 3 6 9. And what do you see? Oh, I forgot to reverse the last 9 6 3. And oh my god, what is this? Both are equal. You have solved the problem. Yeah. See, yeah, so the question is pretty straightforward, and the solution is much more straightforward than the question itself. So yeah, it just involves transposing the matrix and reversing each row. So let's just finish it up quickly. For I in range length of matrix, in range I plus 1 to length of matrix. Yeah, in programming languages, so like C++ and all, what you have to do is you have to take a temporary variable, and what you have to do, temp is equal to matrix position I at the position j, position I at the position j will become equal to position j at the position I, and at the position j at the position I will become equal to temp. This is how you interchange two values, but in Python, rather than going through this hassle, we can directly write it as the position I at the position j, the position I is equal to position j at the position I and position I at the position j. Yeah, this will directly interchange the values for us. And after writing each line, be sure to debug your code once and see if what you're doing is proper. And yeah, as you see, the output you got is the transposition of each matrix. And now the remaining part is pretty straightforward. For I in I is equal to, in Java and all, you have to use collections dot reverse of array and all, but in Python again we can do the position I, and yeah, this is telling go through each step in the reverse order. -1 signifies the reverse order, and then yeah, let's check it out once. Oh, yeah. First you have to debug it, not directly submit it. By mistake, I directly pressed submit, and there you go. It works, and on submission, let's go. You solved it. Yeah, it obviously requires like very little memory. This is for storing the temp variable. This will automatically create the temp variable and swap the elements. For that, 97% memory. It beats 97%, not 100%. And yeah, time is also pretty obvious because we have to go through two. We have to use two for loops for that, and there will be multitude of submissions. And yeah, again, as I told, the submission time depends upon your current internet speed. So it might not look efficient, but it is the most efficient. So yeah, thank you for watching till now, and good luck.